This is my predicted paper for Paper 2 Foundation on the 4th of June 2025, now that we've seen what's come up on Paper 1. This is a best guess though, and no one can know for sure what is going to definitely appear. So just lots of common topics, things we haven't seen yet, and just really good things to revise ahead of Paper 2. So let's get into it. Question number 1, write down the value of the 5 in the number 3,507. So we're going to write 500. You could also write 500s, but a lot of students, when they have this question, write hundreds. And yes, that is the column that it's in, but that is not going to give you the mark. You need to say 500s or 500. That is the value of that digit. Question number 2, write 52% as a fraction. Give your answer in its simplest form. So percent means out of 100. 52% means 52 out of 100. And then we're looking to simplify that. They're both even, so they're both in the 2 times table. So I'm going to divide by 2. And dividing by 2 gives me 26 over 50. And then they're both even, so let's divide that again. 26 and 50 divided by 2 on the top and the bottom gives me an equivalent fraction of 13 out of 25. And you could have just divided by 4 to begin with, but that would be my answer there, 13 over 25 to get the second mark. If you only got as far as one of these, then you would have got 1 mark there for that one. Question number 3, write the following numbers in order of size, start with the smallest number. When we are ordering decimals, my hack here would be to write them over the top of each other, lining up your decimal point. So 0.48, 0.4, 0.045 and 0.05. And what I'm then going to do is make them all the same length by using zeros to hold the place value in any of those gaps. So now it's a little bit easier to see. You can compare 480 versus 400 versus 45 versus 50 if you find that easier. But we're looking in the tenths column first, and we've got 4400. So the smallest two are going to be the decimals that have 0 in that tenths column. And then moving over, it's a 4 versus a 5. So this one, the one with a 4, is going to be the smallest, 0.045, and then 0.05 is going to be second smallest. Now we're going up here to look at the two that have 4s in that tenths column. Moving over to the next column, the hundredths column, I've got 8 versus 0, and it's going to be 0 that's the smaller, so 0.4 is next, and then 0.48 at the top there as the biggest decimal. Question number 4, round 34.785 to 1 decimal place. 1 decimal place means one number after the decimal point. So 34.785, we want this, and then we chop it and we check it. And given that the next digit is an 8, that rounds up. So it's going to be 34.8. The 7's going to become an 8. If this value, this number here, had been 4 or below, then we would have rounded down and it would have stayed a 7 in the tenths column. If we were asked to round this to one significant figure, then rather than counting from numbers after the decimal point, you're counting from the first digit that isn't a 0. So that 3 there, that would be my first significant figure. Check the next number, it's a 4 which rounds down, so to one significant figure the answer would be 30. But here we were asked for decimal places, so 34.8 is your answer there. Question number 5, write down all of the factors of 24. So when we're writing down factors, we need to think about the numbers that fit in an exact number of times. So I'm going to start with 1, and 1 and itself is always going to be a factor, so 1 and 24. Then does 2 go in? Yes, it does 12 times. 3 goes in, and it's 3 times 8 to make 24. 4 goes in 6 times, and 5 doesn't go in. And we don't need to worry about 6 because we've already got it on that side, and that means we've covered them all. So I'm now just going to write that out in order. 1, 2, 3, 4, 6, 8, 12, 24. If you didn't write them in order, that's absolutely fine. It wouldn't matter, but you would need to get all of them in order to get both marks there. Question number 6, simplify 12 minus 5c, add 2b, add 3c minus b. And here we need to collect like terms. So I'm going to look at the 12, and that is the only term that is a constant term, the only one without any letters. So that can't go with anything else. Then let's have a little look at the minus 5c and the add 3c. And thinking about that, if I'm at -5 and I add 3, I'm going to come up towards 0. So if you're at -5 on the number line and you add 3, you're going to go this way, -4, -3, up to -2. You're adding, so you're going that way, adding 3. So we've now got -2c. And then we've got 2b, and we're taking away b. Now remember, a b on its own is the same as 1b. So 2b, take away 1b, leaves me with 1b. So that's going to be add 1b. We've got one positive b there. And the 12 had to stay as it was. Now you can write those in any order, but the 2c did have to be negative, and the 12 and the b needed to be positive. So 12 minus 2c, add b. You can write 1b if you like. You can write just b. Really, it should be just b, but 1b, they won't take any marks off you for that. That's fine. Part B, 7 times a times t times 4. And we're multiplying here, so we don't need to worry about like terms. We can just go ahead and do it. 7 times 4 is 28, multiplied by a, multiplied by t is 28at. So I can just smush it all together when I'm multiplying. And then part C, we've got an equation. And when we're solving equations, we want to use a dotted line where our equals is. And what we do to one side, we're going to do to the other. I'm going to start though by multiplying out the bracket, expanding the bracket. So when we see a number outside a bracket like this, it means 4 lots of everything in the bracket. So I'm going to do 4 lots of the first thing and 4 lots of the second thing to get rid of this bracket. So 4 lots of 2x is 8x, and 4 lots of -5 is -20, and that equals 28. I've not done anything to both sides, and I've not taken away or added. I've just changed the way that it's written by multiplying out that bracket. So now we've got 8x minus 20 equals 28, and I'm going to add 20 to both sides, because by doing that, I'm going to get rid of the -20. So this would cancel with this and leave me just with 8x. However, if I've added 20 to one side, I also need to add 20 to the other side. So that is going to be 48. And I'm then going to divide that by 8, divide this side by 8, and divide this side by 8, because I've got 8 lots of x, and I don't want 8 lots of x, I just want 1 lot of x. So 8x divided by 8 is x, and 48 divided by 8 is 6. So x equals 6 is my answer there for 3 marks. Question number 7, work out 46% of 240. So 46% of 240, you might feel happiest doing this without your calculator. 10%, we would get that by dividing by 10. So 10% would be 24, and you could do 4 of those. So 40%, if we multiplied that by 4, would be 96. And then you could get 5%, we would get that by halving 10%, so that would be 12. And then 1% you would get by taking 240 and dividing it by 100. So that would be 2.4. And you could then add those things together to get your answer. And we'll do that in just a second. However, you do now have your calculator. So 46% is, as a decimal, 0.46. To get from percentage to decimal, you divide by 100. If you want 46% of a number, you can just do 0.46 of, which in maths is multiplication, 240. So we can just take 0.46 and multiply it by 240, and that gets you 46% of 240, and that is 110.4. Let's just check the other way. 96, add 12, add 2.4, and that also gets me 110.4. Nothing wrong with either of those methods. You do it whichever way you feel most comfortable with. Question number 8. Here is a triangle drawn on centimetre grid. On the grid, draw a rectangle equal in area to this triangle. Find the perimeter of your rectangle. So let's start by working out what the area of this triangle is. We can see that it has a base of 7, 1, 2, 3, 4, 5, 6, 7, and the height has to be perpendicular. You can measure it at the side if you want, or you can measure it in the middle, but it needs to be at right angles to that base. When you're doing area of a triangle, it's base times perpendicular height divided by 2. So the area of this triangle is 7 times 4, and then because it's a triangle, we know that we need to divide by 2, either half base times height or base times height divided by 2. 7 times 4 is 28, divided by 2 is 14. So this is 14 centimetres squared. I now need to draw a rectangle that is 14 centimetres squared. And to do that, I need to think of two numbers, because for a rectangle, it's just base times height, two numbers that multiply together to make 14. And I'm going to do 2 times 7. You could also do 1 times 14, and I guess that you could probably do 4 times 3.5, but we would want to stick to whole numbers here. So I'm going to do 2 times 7. 2 times 7 is 14. So I'm going to make it 2 tall, and then I'm going to make it 7 wide. 1, 2, 3, 4, 5, 6, 7. 2 tall and 7 wide. If you did it a different way, you could have done 3.5 times 4, that would have worked. And so your answer for your perimeter is going to be different. But I'm hoping most of you did it this way as it's the most obvious. So now for the perimeter is the distance around the outside. So I'm going to do 7 add 2, add 7, add 2. 2, add 7, add 2, add 7, and that is going to be 18. So 18 centimetres would be the units, because it's just the length going around the outside. So the perimeter is the distance around the outside. The area for a rectangle is base times height. Okay, question number 9. Here is a list of numbers. Juliet says to work out the mean, you need to put all of the numbers in order and find the middle number, so the mean is 10. Juliet is wrong. What has Juliet calculated? So the method she's described there, when you put all of the numbers in order and find the middle number, is working out the median. So Juliet has calculated the median. Rather than the mean. And then it says calculate the actual mean for the data. And to work out the mean, we add all of those numbers together and divide them by how many there are. So 10, add 29, add 14, add 7, add 6, add 23, add 8. We're going to add all of that together. 10, add 29, add 14, add 7, add 6, add 23, add 8. And that is 97. You're then going to divide that by how many numbers there are. 1, 2, 3, 4, 5, 6, 7. 97 divided by 7 gives me an answer of 13.857. Let's just do 13.857. I'll write that there. Lovely. Great. 13.857 would be my answer for that one. Question number 10. Tom is going to have a meal. He can choose one main course and one dessert from this menu. And the menu is, main course is pasta, burger or fish. And for dessert, it is sorbet, jelly or mousse. That took so many takes. Write down all the possible combinations Tom can choose. So he can either choose pasta with sorbet, pasta with jelly, and pasta with mousse. Feels like a tongue twister. Or he can pick burger with sorbet, burger with jelly, and burger with mousse. Or he can pick fish with sorbet, fish with jelly, and fish with mousse. And you'll notice that I picked all different starting letters, and they tend to do that so that if you just use the first letter, we'll know exactly what you mean. So don't spend ages writing it all out. It's absolutely fine to use those. And make sure it's nice and clear. I see a lot of these where students write pasta and this and this and this, and it all just looks really muddly. Leave some gaps and make sure it's nice and clear which ones you are referring to. Question number 11, a shop sells grass seed in 800 gram boxes or 2 kilogram bags. Here is some information about the cost of the grass seed at the shop. We've got an 800 gram box for £3.75 and the 2 kilogram bag for £9.50. Which is better value for money, the 800 gram bag or the 2 kilogram box? So what we have here is two prices and two different amounts. What we're going to want to do is make the amounts the same. So on the left hand side here, I'm going to write 800 grams equals £3.75. And on the right, I'm going to say 2 kilograms. Now, let's get these in the same amount. So 2 kilograms is the same as 2,000 grams. There are 1,000 grams in a kilogram. So I'm going to put 2,000 grams equals £9.50. And what we want to do is make the amount the same. So you can pick any two values you want that are the same. You could times them up to go to 4,000. That would work. 4,000 is in the 800 times table and the 2,000 times table. I'm actually going to divide it down. So I'm going to say 100 grams. How would I get to 100 grams? I would divide that side by 8. And on this side, to get to 100 grams, I would need to divide by 20. So then we're going to do the same to the price. If I divide this price by 8, I will get the 100 gram price. And if I divide this price by 20, I would get the price there. So let's now do that using your calculator. £3.75 divided by 8 gives me a price per kilogram of 0.46875. And then on the other side, £9.50 divided by 20 gives me a price of 0.475. So on the left-hand side, the price is 46.8 pence per 100 grams, and on the right-hand side, 47.5 pence. So we can see that on the left-hand side, the 800 gram box is actually better value. It is cheaper per 100 grams. So 800 gram box is better value. And you might have done it a different way, but ultimately what you need to do is get the same amount in both. So get 4,000 grams or 4 kilograms, something like that, that would then be comparable, and you can see which one is more expensive and cheaper for the same amount. There we go. Question number 12. The value of x is a prime number which is bigger than 24 and less than 30. Calculate the value of y. So prime numbers are numbers that have two factors, 1 and themselves. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11, 13, 17, 19, 23, and 29. And that's all of them up to 30. Now, looking at the ones that this could be, 23 is too small. 29 is the only value that could be x. 29 is the only prime number between 24 and 30. So if x is 29, we now need to work out the value of y. And to get that, we know that this is angles around a point. Please, 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 please do not say angles in a circle. It's a really, really common mistake. I know it looks like a circle, but that's just the way we're labeling the angle. And we need to say, if there was, here there's no reason. It doesn't say, please give a reason. But if it said, give a reason for your answer, we need to say angles around a point. So here I'm going to do 360. I'm going to take away 29 to get the value that's left, and that is going to be 331 degrees. So y is 331 degrees. Angles around a point add up to 360. Question number 13. ACD is a straight line. Work out the size of angle CBD. Give a reason for each stage of your working. Okay, let's start here. I know that this angle here will add with 51 to make 180, because angles on a straight line add up to 180 degrees. So that'll be 180, take away 51, more on the floor, borrow from next door. 10 take 1 is 9, 7 take 5 is 2, so 129 there. And then this angle up here is the one they asked me for, CBD, and that is going to add with the other angles in that triangle to also make 180. So this one, angles in a triangle, add up to 180 degrees. And then let's just add these two together and take it away from 180. So 129 add 31 is 160, and then 180 take away 160 is 20. So 20 degrees is my missing angle up there. 20 degrees would be my answer. That is the size of angle CBD. It's absolutely fine, by the way, to annotate the picture. It's actually quite helpful when you're examining, when people write it up there on the picture. Question number 14. Neil left his home at 8 a.m. and walked to the supermarket. The supermarket is 2.5 miles from his home. He got to the supermarket at 8:40 a.m. Work out the average speed Neil was walking at. So we're going to need our formula triangle here. Speed, distance, time. The D is on the top. Speed, distance, time. And we know that the distance is 2.5 miles and the time is 40 minutes. From 8 until 8:40, it is 40 minutes. Now, I need to get that in hours. I've got 40 minutes, but I know the speed is in miles per hour. So if I'm going to do the speed, distance divided by time, I need to do miles divided by hours. So I'm going to do 2.5 divided by, now how am I going to get 40 minutes in terms of an hour? Well, it's 40 out of 60. There are 60 minutes in an hour. So in my calculator, I'm just going to do 2.5 divided by 40 out of 60, and that's going to give me my answer. So 3.75 miles per hour is our answer there. Neil spent 38 minutes in the supermarket and then walked home. He took 50 minutes to walk home. At what time did Neil get home? So we know he arrived at the supermarket at 8:40. He spent 38 minutes in the supermarket. So I like to do this by moving along. I know that 20 minutes would get him to 9 o'clock. So I always like to go to the next hour. And then if we're trying to add on 38 and I've added on 20 to get to 9 o'clock, I've got another 18 to go. Because these two would then make 38. And so 9:18 is when he's done at the supermarket. Then he walked home and it took him 50 minutes to get home. So again, let's do the same thing. How many minutes to get to 10 o'clock? And if there's 60 minutes in an hour, you're already at 18. So 60 take away 18, we've got another 42 minutes to go. So I've used 42 of the 50 I've got to add on, and then it would just be another 8. So 42 and 8, that's going to be the 50 altogether. And that means that he finally gets home at 10:08 a.m. for that one. Question number 15. There are 400 stickers for sale in a store. Sally buys 5/8 of the stickers. Sally then gives 3/5 of her stickers to Shona. Write the number of stickers Sally now has to the number of stickers Shona has. Give your answer in the form 1 to n. So firstly, let's work out how many Sally buys. So 5/8 of 400. We are going to divide by the bottom and then times by the top. So 400 divided by 8 is 50. And 50 multiplied by 5 is 250. Or you do now have a calculator. So if you want 5/8 of 400, you can just type 5/8 times 500 in your calculator. That will do that as well. So 250 is how many Sally has bought from the shop. And then Sally gives 3/5 of her stickers to Shona. So we now need to do 3/5 of 250. And that's how many Sally is giving to Shona. So we're now going to divide by 5. And times by 3. So 250 divided by 5 is 50, and 50 times 3 is 150. So that's how many she's giving to Shona. Now we've got to write, give the number of stickers Sally now has. So Sally doesn't have 250 anymore. She's just given 150 of them to Shona. So if we take 150 away, Sally now has 100. So Sally on the left now has 100 stickers. And Shona on the right, we know has 150. And we need to give our answer in the form 1 to n, which means we want to make the number on the left 1. And to get that, we've divided that number by 100. So we also need to divide the other number by 100. And we're not normally allowed decimals in ratios unless it says it has to be in the form 1 to something or something to 1, in which case you've got to do whatever makes the side of the ratio they're asking for 1 to be 1. If that makes sense. So dividing that by 100 is 1.5. So my final answer here is 1 to 1.5. That is the ratio of the stickers that Sally and Shona have. Okay, question number 16. 70 students from year 10 and year 11, let's pop that straight away down in the total. 70 students from year 10 and year 11 are asked their favourite hot drink from coffee, tea and hot chocolate. 33 students are in year 10, okay, that's the total number of year 10 students. 18 of the 20 students who said coffee, so coffee is the first column. 18 of the 20 students who said coffee are in year 11, so 18 year 11s out of 20. 12 year 10 students preferred tea, and 19 students preferred hot chocolate. So that doesn't say what year group they are, so 19 preferred hot chocolate is there. Use the information to complete the two-way table. So we now just need to fill in all the gaps. There must be 2 year 10s that said coffee, because we know that 2 and 18 need to add together to make 20. I also know that there must be 37 year 11s, because I need these two values here to add together to make 70. Once I know that, coffee and tea, this is 14. So I'm going to do 33, take away 14 to work out how many year 10s said hot chocolate. More on the floor, borrow from next door. 13 take 4 is 9, and 2 take 1 is 1, so 19. No year 11s said hot chocolate, because we've already got the 19 there, which means the rest of them must have said T. So let's now do 37, take away 18, more on the floor, borrow from next door. 17 take 8 is 9, and 2 take 1 is 1. There we go, so 19 there. 12 add 19 is going to be 31. So that's how many said T. And you might just want to check at the end, whatever the last calculation is, 20 add 31, add 19, that does indeed add up to 70. So I'm happy that that is correct. Okay, then it says one of the students who preferred T is chosen at random. Now this is really important. That sentence tells you who you are picking from. So if I said a student is chosen at random, it would be out of 70. If I said a year 10 is chosen at random, it would be out of 33. If I said a year 11 is chosen at random, it would be out of 37. But I didn't say any of those things. I said one of the students who preferred T is chosen at random. So we are only picking from the students who chose T, and there are 31 of them. So this is going to be out of 31. What's the probability the student is in year 11? We are only picking from these children. And so the probability they are in year 11 is 19 out of the 31 children who said T. What was the modal choice of hot drink? So the mode is the most common. Looking at all the hot drinks, 20 students said coffee, 31 said tea, and 19 said hot chocolate. So it's going to be 31, the frequency for tea, that leads us to our modal, the mode, the most common. So the most common choice of hot drink is going to be tea. There we go. Question number 17. Here are the first 5 terms of an arithmetic sequence. We've got 2, 9, 16, 23, and 30. Find an expression in terms of n for the nth term of the sequence. So first thing we need to do is look, what are we going up in? So 2 to 9 to 16 to 23 to 30 is going up in sevens. So when we know what we're going up in, that's the difference. We're going to put the difference in front of an n, 7n. Now the 7 times table starts on a 7, and then it goes 14, and then it goes 21, and then it goes 28, and then it goes 35. So how am I going to get from starting on a 7 to it being a 2? How am I going to get from it being 14 in the second term to it being a 9? And that is 5 less. So it's the 7 times table, but 5 smaller, because the 7 times table would start on a 7, and we're actually starting on a 2. Now, if that's tricky and that doesn't make sense to you, there is another little sneaky hack, which is to imagine what number would be in that red box. So if you go to the first term, the first number in the sequence, and then you go 1 in front of that, to the 0th term, let's call it, what number would go there? Well, you'd have to go back by 7. And if you went back by 7 from 2, you'd get down to -5. And that value in the red box will always match the shift. So 7n minus 5 would be my nth term for that one. Question number 18. Simplify m cubed to the power of 5. And a power of a power, we are multiplying those together. So that's m to the power of 15. If you had t squared times t to the 7, then we're multiplying, so we would add the powers. So if you're multiplying, add the powers, but if it's a power of a power, you're going to times the powers together. Okay, for part B, I've got 3x squared y to the 4 times 3x squared y to the 4 times 3x squared y to the 4. And I'm multiplying this by itself and by itself again. 3 times 3 times 3 is 27. X squared times x squared times x squared is x to the power of 6. And y to the power of 4 times y to the power of 4 times y to the power of 4 is y to the power of 12. So I've multiplied and I've added them together. Okay, part C, expand and simplify. So I'm doing 5 lots of x and 5 lots of 5, which is 5x add 25. And then I'm taking away 2 lots of everything in the second bracket. So minus 2 lots of x and minus 2 lots of minus 3. Minus 2x is minus 2x. And then if I've got minus 2 lots of minus 3, a negative times a negative is a positive. And now we can collect up our like terms. I've got 5x, take away 2x, which is 3x. And then I've got 25, add 6, which is positive 31. 3x add 31 would be your answer there. Question number 19. Georgia makes cookies after a long afternoon of revising. She mixes peanut butter and caster sugar in the ratio 8:7. She uses 200 grams of peanut butter. Work out the amount of caster sugar she should use. So if our ratio is 8:7, I find it easiest to visualise this if we go 1, 2, 3, 4, 5, 6, 7, 8 on this side, and 1, 2, 3, 4, 5, 6, 7 on this side, where we know that these piles represent the peanut butter and these piles represent the caster sugar. So the peanut butter is just on the left-hand side of that ratio. It's not all of it. We're not going to divide by all of the piles because it's just going on the peanut butter side. So therefore we need to do 200 divided by 8, and that is 25. And that tells us that all of those little lines have a value of 25. 25, 25, 25, 25, including the other side as well. That's how ratio works. If we can work out what the value of one of those parts is, then we've got them all. Okay, so I now know that for caster sugar, it's going to be 7 lots of 25. So 25 multiplied by 7, 7 times 5 is 35, and 7 times 2 is 14, add the 3, so 175 grams of sugar. Question number 4, Jake buys a pair of trainers for £80, he sells them for £135, work out his percentage profit. So percentage change, that's a percent by the way, percentage change or percentage profit is going to be the extra over the original times by 100. So change over original times by 100. How much has it gone up by? Over the original times by 100, or how much has it gone down by? But here we're looking at going up. So the difference, the change, is going to be 135 take away 80 over the original. And the original is how much money he spent out. So that's going to be 80. And then to get that as a percentage, we are going to multiply it by 100. So that's going to be 55 over 80 multiplied by 100. And that gives us a percentage of 68.75%. Question number 5. A number h is rounded to 1 decimal place. The result is 3.0. Write down the error interval for h. So if it's been rounded to 1 decimal place, it could have been rounded to 3.1. But it didn't. We've got 3.0, could have rounded to 2.9, but it didn't. And we know that if it's rounded to 3.0, then it must have fallen in this range here, where 3.0 is the closest. So we're going to take 1 decimal place, which is rounding to the nearest 0.1, and we always half that. So if they rounded to the nearest 10, you would half that, do 5 above and 5 below. If they rounded to the nearest 1, you would half that, do 0.5 above and 0.5 below. Because they've rounded to the nearest 1 decimal place, we've rounded to the nearest 0.1. So we're going to half that and put 0.05 above and 0.05 below. So that's going to be 3.05 at the top and 2.95 at the bottom. That is how out your answer can be, how much the error can be in getting to 3.0. Now you might think, well, hang on, 3.05 would round up to 3.1, and you're absolutely right. But because we can go so infinitely close to it, so you could do 3.04999999 recurring, which goes so infinitely close that we just call it 3.05. We just don't have the equal to at that top end, and that means that it can go up to 3.05 but not actually equal that value, in which case it would round up. Question number 6. The shape below is made from a right-angled triangle and a sector. Work out the perimeter of the shape, give your answer correct to 1 decimal place. So here what we need to do is work out the perimeter of the triangular bit and then go round the sector as well. So the area, the perimeter, that we're looking for is going to be this bit, this bit, this bit, and this bit. So in order to do that, I've got the 9, I've got the 6.4, but what I need to work out is the arc length, the bit of the sector that goes around the outside. So let's have a look at that. In order to work out the circumference and therefore the arc length, I'm going to need the radius, and that's going to come from this side here. Now looking at this, we have a right angled triangle where I know 2 sides and I want the 3rd side, and that is the perfect setup for doing Pythagoras. So here I'm going to do 9 squared, take away 6.4 squared, and then I'm going to square root my answer. And you might be thinking, why are you taking away? And the answer for that is that 9 is the hypotenuse. It is the longest side of that right angled triangle because it's over from the right angle. 9 squared take away 6.4 squared is 40.04, and then we just need to square root that to get the length of the radius, which is this value here, and that is going to be 6.32771. I don't want to round it too much just yet. I'm going to write it down here as well, 6.327716808, because I am going to carry on and use that. Now, in order to work out the circumference of the circle, I need to do pi times diameter. And the diameter would be all the way across the circle. Now, I've only got the radius at the minute because I've only got the line that goes from the middle to the edge. So I'm actually going to double that. And that's going to get me 12.6. So the diameter is 12.655433. And then I'm going to do pi multiplied by 12.655 in order to get the whole circumference. Except I don't want the whole circumference. I only want 155 degrees out of 360. So I'm going to multiply by that. So the diameter multiplied by pi multiplied by 155 out of 360. That's what I'm typing in my calculator. And that gives me the arc length. So from B round to C is 17.11812133. And that then is that part. And then I also need the radius again, don't I? So this bit here, we know from before is 6.3277. We've got that down there from when we did Pythagoras. I now just need to add all of those values together. So the 6.4, the 9, this bit here, the 17.118, and the 6.3277. I don't want this one, because that's not on the outside of the shape, that's not forming part of the perimeter. So 17.118, add 6.3277, that'll be enough decimal places, add 9, add 6.4, adding all of that together, I get 38.845821. We're asked to round it to one decimal place, so let's go 38.8 on that one. 1, 2, 3, 4, yeah, got all the sides. So 38.8 would be my answer there. And that is in centimetres because it is a length. Okay, question number 7. The frequency table gives information about the length of 60 shoelaces. Find the class interval that contains the median. So class interval is just a posh way of saying category. It is asking you which of these categories has the median in it. So let's put category there so we know what we're talking about. Which of these categories contains the median? And the median is the middle value. Now we're told that there are 60 shoelaces. Normally, to find the median, we would add 1 and divide by 2. If you imagine 60 pieces of data, actually to split them, we would have 30 on that side, 30 on that side. So the median is going to fall between the 30th and the 31st. So I'm looking, where is the 30th and the 31st piece of data? I've got 8 in the first category. They're the smallest shoelaces, and I've got 8 of them in that category. So I've not reached the middle value yet. 8 add 9 takes me up to 17. So at this point, I've still not reached the middle. I've got 17 pieces of data up to that point. And then when I add on 14, that takes me up to 31. So I know that both the 30th and the 31st piece of data is in that category there, 10 to 15. So that is the class interval, the category that has the middle value in it, the median. On the grid below, draw a frequency polygon for the information in the table. If you are drawing a frequency polygon, it is Polly the shark. So we are going to make a shark fin shape, and Polly lives in the middle of the ocean, which reminds us to plot in the middle of the category. From 0 to 5, we have a data point of 8. Be really careful what you're going up in. If you look at this graph, that's 6, that's 7, that's 8. So there we go. We've got that first value there. 0 to 5, I'm plotting 8. 5 to 10, I'm going up to 9, which would be there. 2 squares representing 1, guys. 10 to 15, I'm going up to 14. And then 15 to 20, I'm going up to 18. And then 20 to 25, back down to 11. And I did make it a very typical shark fin shape, but it might not happen like that. I did have a year where my lovely year 11s came out and said, Miss, Polly had two fins and it went up and down and up and down. It's not that it's going to always make that shark fin shape. It's just to remind you not to draw bars, not to do a smooth curve. It's a pointy shark fin, and always to plot in the middle of the category because Polly the shark lives in the middle of the ocean. I know it's silly, but it helps you to remember what to do. So that would be Polly the shark, a frequency polygon, and it looks like that. Don't join it up to the origin. Polly does not want to be joined up to the beach, and don't chop her body off. She's all good. She's a free thing. She floats about in the middle of the ocean. There you go, Polly the shark. If you know, you know. Okay, question number 8. The probability tree diagram shows the probabilities of Alan being late or on time to school on 2 days this week. So we've got Monday and we've got Tuesday. Calculate the probability that Alan will be late on Monday but on time on Tuesday. And this is purely here as a reminder, if you get a tree diagram, number 1, your branches, the probabilities on your branches need to add up to make 1. And also if you want to go along the branches, we multiply. So late on Monday, on time on Tuesday, this is the pathway that I'm looking at. I'm going to do 0.1 multiplied by 0.95. And if you want more than one pathway, you multiply along the pathways and then you add the ones you want up at the end. Here we only wanted this pathway, so I'm going to do 0.1 times 0.95, which is 0.095 is your answer there for 2 marks. Question number 9, work out the value of this. So this is testing your ability to use your calculator. The first thing you're going to do is press the square root. Because my square root goes all the way around the fraction, I want to press the square root button, this one, first. If I press the fraction button first, and then I press the square root is only going to go on the top. So just make sure the square root, have a look at your calculator display. Is the square root going all the way around or is it just on the top? And here we're going to press the square root first and then the fraction button to make sure it goes around it all. 0.827 cubed, add 61.018, then go down to the bottom and we've got 32 cubed minus 1. And that gives me an answer of 0.043352500816. That's all of the figures on my calculator display. I would say do about 7 or 8 at least, right? I mean, for me, there is about 10 and it doesn't exactly take long to write it down, but always make sure you don't round that. Give your answer to part A in standard form, correct to 2 significant figures. So now we're having to write this in standard form and also round it. So rounding it to 2 significant figures, my first significant figure is that 4. And my second significant figure is the 3, because we only start counting significant figures when we reach a value that isn't 0. We do count zeros, so like this one would count, because then at that point we've already started counting significant figures. But this is my first significant figure and this is my second. I then want to chop the number there, check the next value. So checking the next value is a 3, which would round down. So 0.043 is rounding it to 2 significant figures. Let's then write that in standard form. So standard form is a number between 1 and 10. So we're going to go 4.3 multiplied by 10 to the power of something. And if you want to go smaller, you're going to be dividing by 10, dividing by 10. If you want to go bigger, you'd be multiplying by 10, but we do that in the power. So a positive power means we are timesing by 10, and a negative power means we're actually multiplying by the reciprocal of 10, which is going to divide it. So because here I want to go divide by 10, that's the same as multiplying by 10 to the power of minus 2. So a smaller number there is going to be times 10 to the power of minus something. We needed to move those digits 2 place value columns over, and that's why we had the 2. Question number 10. Use algebra to solve the simultaneous equations. Now here we have linear simultaneous equations, and I've gone for a slightly controversial one in that I know that a lot of you will multiply this top one by 2, and then you'll have 6x add 14y is minus 24. And the bottom one, we would just keep that the same. 6x minus 2y equals 8. What happens when students make this one the same, which is great, that is an absolutely valid method, but what happens is you forget that you're looking at these signs. So I've actually there, because it's positive 6 and positive 6, what you'd want to do is take away. But often, because you can see them, students still look at these symbols and then they want to add. So that's the first reason that can go wrong. So just be aware of that. If you're making the first thing the same and there's nothing in front of them, then they are positive. And so to cancel them out, you are going to be taking away. The other thing you need to be really wary of is then you would be doing 14 minus 2, which is going to add it on. So 14 minus 2 would add it. Be really careful if you're subtracting and it's negative. So I think for that reason, what I often do, and there is absolutely nothing wrong with doing it that way, just make sure you don't fall into that trap, I'm actually going to make the middle terms the same. Now, it doesn't matter. You'd get the same answer either way. I just find that students tend to go wrong less if they're making the middle terms the same, just because you can see those signs, but that's just me. I'm going to multiply the top one by 2, I'm going to multiply the bottom one by 7 in order to make both of these 14. So that would be 6x add 14y is minus 24, and at the bottom 42x minus 14y is 56. And now because I've got one positive and one negative, I'm adding, and I just find that slightly easier and find it tends to go wrong less often, but completely up to you. 48x then, and minus 24 add 56 is going to bring me up to 32. We're then going to divide both sides by 48, and 32 divided by 48 is going to be 2/3. Once I know that x is 2/3, I'm going to put that back into either of my equations. I'm going to go for the top one. So 3x add 7y is minus 12. And let's now make x 2/3 because we know that is the value. So 3 lots of 2/3, add 7y equals minus 12. And then 3 multiplied by 2/3, actually that just cancels. So 2 add 7y is minus 12. Take 2 away from both sides, means that 7y is minus 14, and then we can divide by 7. So y is minus 2. Now, if you did it the other way and you made them both 6x, you would have got that minus 2 value first, and it's the minus 2 that you just sub back in, but you would have got the same answers. So 2/3 and minus 2. Now, just in case the simultaneous equations you get are on a graph, remember that to solve simultaneous equations on a graph, you're just looking for the point where they meet. So there you would just give the coordinates of that point, the x coordinate and the y coordinate would solve the simultaneous equations if they were on a graph. The diagram shows a cuboid. The cuboid is made from solid gold and has a mass of 1.536 kilograms. Work out the density of the cuboid. So here we're going to need our formula triangle for density. Density, mass, volume. And we're working out the density. So covering that up and doing the sum that's left behind, that is mass divided by volume. So the mass we have is 1.536 kilograms, but we don't have the volume right now. And to work out the volume of a cuboid, we do length times width times height. 6 times 3 times 4.5 in any order, doesn't matter what order you do it in. So that is 6 times 3 times 4.5, and that gives me an answer of 81 centimetres cubed. Now look very carefully at the answer line. The answer line has my density in grams per centimetres cubed, which makes sense because we're doing a mass divided by a volume. So grams per centimetres cubed. And I've got the volume in centimetres cubed, but my mass is not in grams, it's in kilograms. So we need to change it. And we know that 1,000 grams is a kilogram. So we're going to times it by 1,000. So I've got 1,536 grams divided by 81 centimetres cubed. And to divide that means we're going to get grams per centimetres cubed. We're going to get our density. So 1,536 divided by 81 gives a density of 18.962 grams per centimetres cubed. There we go. Question number 28, expand and simplify. So I've got 3x times x, which is 3x squared, 3x times minus 2, which is minus 6x, 1 times x, which is 1x, and 1 times minus 2, which is minus 2. So 3x squared minus 6x, add 1x minus 2. And you can put the 1 here, it doesn't make any difference whether you do or don't, you'd still get the marks. 3x squared is on its own, that's the only like term there. If you've got minus 6x and you're adding 1x, think about your number line. If you're at minus 6 and you add 1, you're coming up. So that is minus 5x and then minus 2. 3x squared minus 5x minus 2. For part B, we're factorising. Now, when we're factorising, we need to think, is it one bracket or is it two? And the two questions here are the perfect examples. If there is something in common to everything, so like this one here, they're both in the 8 times table, they both have x's, there is something in common to everything, I'm going to use one bracket. If you've got x squared, 8x and 15, there is nothing in common to all three terms, and this is going to tell me that it needs to be two brackets. And it's going to be x at the start here and x at the start here. And I'm looking for two numbers that add to make 8, the number in front of x, and multiply to make 15. And what I like to do is an arrow off of the 15 and write together the options of numbers that would multiply to make 15, either 1 times 15 or 3 times 5. Now, looking at those pairs, which of those pairs is also going to add to make 8? It's going to be the 3 and the 5. So x add 3, x add 5. If you multiplied that out, you would get x squared, add 5x, add 3x, add 15. So that works. We needed two numbers that added to make the middle number in front of the x and multiplied to make the constant term. You can have it the other way around, so you could put that as your answer as well. Wouldn't make any difference as long as they were both positive. And then down here on C, I'm looking for a number that goes into 16 and 24, and it needs to be the biggest number it can be. 4 is a common factor, but 8 is also a common factor, and that's bigger. So we're going to put 8 on the outside. They also both have an x, and they also both have a y, and we can't go any higher than that because this y is just y, and this x is just x. So what do I then need to multiply 8xy by to get 16x squared y? We know it's going to need a 2 because 8 times 2 is 16. And we know it's going to need an x because x times the x would be x squared. We don't need a y because we've already got that on the outside and there isn't any more. Add. 8 times 3 is going to give you the 24. I've already got the x coming from the outside. I've already got a y, so I need y squared more because y times y squared would give you y cubed. And that is your answer there. Quite a tricky back page, so hopefully that made sense and you were able to follow along. And that is it. 80 marks, all topics that are commonly seen, but we haven't seen them yet on the paper one. I really hope you found it helpful. Please let me know in the comments if you've got any questions and I will do my best to get back to you and explain why. And yeah, great. Thank you so much for being here. Happy revising, and I very much hope your exam goes well.